Hello grade 9 students, I'm back. Um, let's continue our lesson on the properties of quadratic functions. This is now part 4. So our lesson here is properties of quadratic functions in standard form. Let's first have a warm up. Give the coordinate of the vertex of each function. Okay, that's easy. H is 2, K is 3, so therefore the vertex is 2, 3. How about here? What's the vertex? H is -1, K is -4, so what is the vertex? -1, -4. Now give the domain and the range of the following function. So the domain is -2, 0, 2, 4, while the range are 4, 6, 8, 10. Objectives for this topic: define, identify, and graph quadratic functions. Identify and use maximums and minimums of quadratic functions to solve problems. These are the vocabulary to be used in this topic: axis of symmetry, standard form, minimum value, maximum value. When you transform quadratic functions in the previous lesson, you saw that reflecting the present function across the y-axis results in the same function. So if f of x equals x squared, then g of x equals -x, quantity squared equals x squared. This shows that parabolas are symmetric curves. The axis of symmetry is the line through the vertex of the parabola that divides the parabola into two congruent halves. In words, the axis of symmetry is a vertical line through the vertex of the function's graph. In algebra, the quadratic function f of x equals a times quantity x minus h squared plus k has the axis of symmetry of x equals h. And this is the graph, right? Vertex is hk. Axis of symmetry is the red line. Now identify the axis of symmetry for the graph. F of x equals -1/2 quantity x plus 5 squared minus 8. Write the function to find the value of h. H is actually this 5. It's positive pi, that means it's -5. Because in the vertex form, x minus h. So you write it x minus h is -5, while k is -8. So the axis of symmetry here is x equals -5. So the axis of symmetry is the vertical line x equals -5 because h equals -5. Analyze the graph on a graphing calculator. The parabola is symmetric about the vertical line x equals -5, 1, 2, 3, 4, 5. Yes, that's right. This is the axis of symmetry of the parabola that opens downward. And then, okay, use your graphing calculator for this. And let's proceed. Identify the axis of symmetry for the graph of f of x equals quantity x minus 3 squared plus 1. So first, write the function to find the value of h. The formula for the axis of symmetry is x equals h. So h is 3. So therefore the axis of symmetry is x equals 3. Yun. The vertical line x equals 3. Next, check. Analyze the graph on the graphing calculator. The parabola is symmetric about the vertical line x equals 3. And this is the axis of symmetry. Analyze this in your graphing calculator. Another useful form of writing quadratic functions is the standard form. The standard form of the quadratic function is f of x equals ax squared plus bx plus c, where a is not equal to 0. The coefficients a, b, and c can show properties of the graph of the function. You can determine these properties by expanding the vertex form. This is the vertex form of a quadratic function. If we're going to expand this, okay, by completing the square, by squaring x minus h, we have x squared minus 2xh plus h squared plus k. Then we have here the final. Simplifying group terms, f of x equals ax squared plus -2ahx plus ah squared plus k, which is the constant c. This is the b and a. A, b, c. So for a, we have a. For b, -2ah. For c, we have ah squared plus k. So a equals a. A in standard form is the same as in vertex form. Yes, it indicates whether a reflection and or vertical stretch or compression has been applied. Solving for h gives, okay, negative b over 2a. Divide both sides by negative 2a. So we have here h. This is now the formula for h, negative b over 2a. Therefore, the axis of symmetry x equals h for quadratic function in standard form is given by the formula x equals negative b over 2a. And axis of symmetry is the same as the x coordinate of the vertex of the quadratic function. Now, notice that the value of the value of c is the same value given by the vertex form of f when x equals 0. So if f equals 0 for the quadratic function in vertex form, we have ah squared plus k. So c is the y-intercept. So when the quadratic function is given in general form, when you're asked to solve for the y-intercept, it is actually the c, the value of c. That's the y-intercept. Another property of parabola here. Parabola opens upward if a is greater than 0 and downward if a is less than 0. We have discussed that in our previous PowerPoint presentation. The axis of symmetry is the vertical line x equals h or x equals negative b over 2a. The vertex is the point hk or negative b over 2a or the function of negative b over 2a. And the y-intercept is c. Okay. So these properties can be generalized to help you graph quadratic functions. When a is positive, the parabola is happy. And when a is negative, the parabola is sad. Yes, because it opens downward. Positive, it opens upward. Example 2a. Consider the function f of x equals 2x squared minus 4x plus 5. Determine whether the graph opens upward or downward. Okay, because a is positive, which is positive 2, the parabola opens downward. Find the axis of symmetry. The axis of symmetry has the formula negative x equals negative b over 2a, which is the same for the value of h, the x-coordinate of the vertex. X equals h, find the vertex of the symmetry. H, b is negative 4, a is 2, so we have negative 4 over 4, positive 1. So the axis of symmetry is x equals 1. How about here? Find the vertex. The vertex lies on the x-axis of symmetry. So the x-coordinate is 1. Diba? Same problem ba yan? Okay. Same quadratic function. So find the vertex. So since h is 1, okay, we will now substitute this to the original here. Original quadratic function. So 2 times 1 squared minus 4 times 1 plus 5 equals 3. So therefore, the vertex is at 1, 3. Okay, so as you can see, the x-coordinate of the vertex is just the same as with the axis of symmetry. Now find the y-intercept. Okay, we have said a while back that y-intercept is actually the c of the quadratic function that is in general form. So as y-intercept is 5. Now consider the function f of x equals 2x squared minus 4x plus 5. Graph the function. So graph by sketching the axis of symmetry and then plotting the vertex and the intercept point 0, 5. Use the axis of symmetry to find another point on the parabola. Notice that 0, 5 is 1 unit left of the axis of symmetry. The point of the parabola symmetrical to 0, 5 is 1 unit the right of the axis at 2, 5. So the axis of symmetry is, okay, yes, we are trying to graph the same function as in previous example, no? So ano ba yung vertex niya? Excuse me. The vertex is 1, 3. While the axis of symmetry is x equals 1. 1, 3. Ito ang vertex. And then it passes through 0, 5 here. I mean here. 1, 3 passes through yan. So yun, the parabola passes through the y-intercept 0, 5. The vertex is 1, 3. And 0, 5 is 1 unit to the right of the axis of 2, 5. Excuse me. Okay, example 2b. Consider the function f of x equals negative x squared plus minus 2x plus 3. Is it a parabola that opens upward or downward? Parabola opens downward because a is negative, negative 1. Find the axis of symmetry. The formula is x equals negative b over 2a. What's your answer? 5 seconds. Time's up. What's your answer? X equals 1, negative 1. The axis of symmetry is x equals negative 1. Because, yes, negative a is negative 1, b is negative 2. Substitute here, x equals negative b over 2a. So, x equals negative 1 is the axis of symmetry. Find the vertex of the same quadratic function. Okay. Since x equals negative 1 ang axis of symmetry, negative 1 is also the x-coordinate of the vertex. Negative 1. Yan. Now, to solve for y, substitute negative 1 here on the original equation. Negative 1 squared minus 2 times negative 1 plus 3 is 4. So, therefore, the vertex is at negative 1, 4. Find the y-intercept. Y-intercept of this quadratic function in general form is actually the c, which is 3. So, the y-intercept is 3 or 0, 3. Now, let us graph this function for 2b. What is the vertex? Negative 1, 4. X equals negative 1 is the x equals negative 1 is the axis of symmetry. Vertex is negative 1, 4 here. Then it will pass through 0, 3 here. So it's downward. It's downward. It will pass through the point 0, 3. Ayun. Okay. Check it out. For the function f of x equals negative 2x squared minus 4x, determine whether the graph opens upward or downward. Find the axis of symmetry, find the vertex, find the y-intercept, and graph the function. So because a is negative, parabola opens downward. Now to solve for the what? B is axis of symmetry, x equals negative b over 2a. So the answer is negative 1. X equals negative 1 is the line of symmetry. How about the vertex? What is axis of symmetry? X equals negative 1. So h is also negative 1. Now substitute negative 1 in this equation. The answer is 2. That is the y value of the, or the y coordinate of the vertex 2. So the vertex is negative 1. And because c is 0, y-intercept is 0. That means the parabola will pass through the origin. So this is now the graph. Axis of symmetry, x equals negative 1. The parabola opens downwards. You can see the vertex is negative 1, 2. And the parabola passes through the point of origin. Yeah. For the function g of x equals x squared plus 3x minus 1. Determine whether the graph opens upward or downward. Find the axis of symmetry, find the vertex, find the y-intercept, and graph the function. So does it open upward or downward? It opens upward because a is positive. Now let's solve for the axis of symmetry. Formula x equals negative b over 2a. Negative 3 halves. Negative 3 halves is the axis of x equals negative 3 halves is the axis of symmetry. Next, find the vertex. Negative 3 halves is the x-coordinate of the vertex. Ayan. So to solve for the y-coordinate of the vertex, substitute x by negative 3 halves here. So negative 3 halves squared plus 3 times negative 3 halves minus 1 is negative 13 fourths. So the vertex is negative 3 halves, negative 13 fourths. And what is the y-intercept? Ito lang, negative 1. The y-intercept is negative 1 or 0, negative 1. Now let us graph. Okay, vertex is negative 3 halves, negative 13 fourths, y-intercept is negative 1, 0, and the axis of symmetry is x equals negative 1.5. Negative 1.5, it passes through 0, negative 1. and it opens upward because a is positive. Substituting any real value of x into a quadratic equation results in a real number. Therefore, the domain of any quadratic function is all real numbers. The range of the quadratic function depends on its vertex and the direction that the parabola opens. So, when the parabola opens upward, it has a minimum value. We've already discussed this in the last PowerPoint presentation. So, what is the domain? All real numbers, a set of real numbers. About the range, when the parabola opens upward, the range is all values greater than or equal to the minimum, which is the k. Y is greater than or equal to k. Yeah, greater than or equal to the minimum. The minimum is yung k. Dito naman, when the parabola opens downward, there is a maximum value. So the domain is all the real numbers. The range is all values less than or equal to the maximum. Maximum is k here also. The k value of the vertex is the minimum or maximum of the quadratic function. The minimum or maximum value is the y value of the vertex. That's what I was saying. The y value of the vertex is the minimum or maximum. It is not the ordered pair that represents the vertex. Finding the minimum or maximum values. Find the minimum or maximum value of f of x equals negative 3x squared plus 2x minus 4. Then state the domain and range. So since this is a parabola that opens downward because a is negative, there is a maximum value for this function, which is the value of ky. Y is less than or equal to k. So it opens downward and has a maximum value. Find the x value of the vertex, which is 1/3. Negative p over 2a, same formula as in the axis of symmetry. 1/3 x equals 1/3 is the x coordinate of the vertex. Now substitute 1/3 on this original equation to solve for the y value of the vertex, then that will be the maximum value. Yun, negative 3 times 1/3 squared plus 2 times 1/3 minus 4 is negative 11/3. So the maximum value is negative 11/3. The domain is the set of all real numbers R, and the range is all real numbers less than or equal to negative 11/3. Also the y coordinate of the vertex. So y is less than or equal to negative 11/3 is the range of the given quadratic function, or y is less than or equal to k. If it's opening upward, it should be greater than or equal. Graph f of x equals negative 3x squared plus 2x minus 4 in a graphing calculator. Alright. Yun. Vertex at 0, negative 4. It has a maximum value. Maximum value is negative 11/3 or yun, 3.333. And ito, 3.67. Next, find the minimum or maximum value of f of x equals x squared minus 6x plus 3. Then state the domain range of the functions. This is a parabola that opens upward, so it has a minimum value. And it opens upward. Now, to determine the maximum value of this, the domain and the range, we need to know the vertex. For the x-coordinate of the vertex, negative p over 2a, which is 3. Because a is 1, b is negative 6, 3 is. Now to solve for the y-coordinate of the vertex, substitute 3 to this equation of the quadratic function. 3 squared minus 6 times 3 plus 3 is negative 6. So therefore, the minimum value is negative 6, the y-coordinate of the vertex. The domain is all set as all real numbers are. The range is all real numbers greater than or equal to negative 6. Or y is greater than or equal to k, the x-coordinate, the y-coordinate of the vertex, which is negative 6. So to graph in a graphing calculator, we have here, as you can see, the minimum is, what's the minimum? The minimum is 6, negative 6. Next, by the minimum or maximum value of g of x equals negative 2x squared minus 4, then state the domain and range of the function. So this parabola that opens downward, so it has a maximum value. Now solve for the domain and the range and the maximum. Let us solve for the vertex. For the x coordinate of the vertex, we have 0. Formula negative b over 2a. Now substitute 0 to this equation to solve for the y coordinate of the vertex, or the value of k, which is equal to negative 4. So the vertex is 0, negative 4, and therefore the maximum value is negative 4, while the domain is all real numbers. The range is, since this is downward, y is less than or equal to k, or negative 4. Now to grab here, that's the maximum value, negative 4. Okay. Now there is a agricultural application of what we are trying to learn here about the maximum and minimum. Example 4. The average height h in centimeters of a certain type of grain can be modeled by the function h of r. H is equal to 0.024 r squared minus 1.28 r plus 33.6, where r is the distance in centimeters between the rows in which the grain is planted. Based on this model, what is the minimum average height of the grain, and what is the row spacing that results in this height? First, we need to know the minimum value of the vertex. First, we need to know the x coordinate of the vertex, which is formula, which has the formula negative b over 2a. Substitute negative b is negative 1.28, negative 1.28 all over 2 times 0.024, which is equivalent to positive 26.67. Now to solve for the minimum, substitute 26.67 in the original function, which is this h of r. So the answer is 16.65. Use your calculator. 26.67 squared times 0.024 minus 128.28 times 26.67 plus 33.6 is 16.5. This is now the maximum height of the grain, 16.5 centimeter, planted at 26.7 centimeter apart. Now graph the example, the agricultural example. Ito na yun. So using your graphing calculator, that's the minimum value there, 16.53. Yeah, 16.5 naman dun sa answer natin. So it's just close. Another, the highway mileage m in miles per gallon for a compact car is approximately by m of s equals negative 0.025 squared plus 2.45 s minus 30, where s is the speed in miles per hour. What is the maximum mileage for this compact car to the nearest tenth of the mile per gallon? What speed results in this mileage? So I think this is a parabola that opens downward, so it has a maximum mileage. So the maximum, let us first solve for s. Negative b over 2a, which is equal to 49. Now substitute 49 to solve for the value of m of s, which is equal to 30. Using your calculator here, negative 0.025 times 49 squared plus 2.45 times 49 minus 30 equals 30. So the maximum mileage is 30 miles per gallon at 49 miles per hour. And using your graphing calculator, we have here, the maximum value is 30.025, close to what we obtained. So for your lesson quiz part 1, consider the function f of x equals 2x squared plus 6x minus 7. Number 1, determine whether the graph opens upward or downward. The answer is upward. Find the axis of symmetry. X equals negative b over 2a is the formula. What's your answer? Negative 1.5. Find the vertex. No need to solve for x. Meron na tayo. Negative 1.5. Y na lang. Substitute negative 3 halves here to solve for y, which has the value negative 1.5, negative 11.5 as the vertex. Identify the maximum or the minimum. It has a minimum value, so this is the minimum, negative 11.5. Find the y-intercept. It's actually the c, so that's negative 7. Consider the function f of x equals 2x squared plus 6x minus 7. Graph the function. So, vertex negative 1.5, negative 11.5, axis of symmetry, x equals negative 1.5, y-intercept negative 7. Yes, it does pass to the y-intercept negative 7. Yun, that's the vertex. Ito naman 1.5, negative 1.5, axis of symmetry. And it opens upward. Find the domain and function. Domain of every quadratic function, all real numbers. While the function is y is greater than or equal to k, which is the y-coordinate of the vertex. And it's equal to negative. Y is greater than or equal to 11.5 as the range. Domain, all real numbers. So that ends our lesson on the properties of quadratic function. I'll see you next time. Goodbye. God bless.